Hi everyone. We are still looking at trigonometry here using the angle addition formulae to solve a couple of problems. We shall end this topic today and then we shall move on to something else. Here we are given that the sine of angle A is equals to 4 divided by 5. And the sine of angle B is equal to 1/2, where A and B are both acute angles. Calculate the exact value of I sine A plus B, sine into A plus B, cos into A minus B, secant, this is secant, into A minus B. So what do we have here is the sine of angles that are acute. So what are acute angles? Because you need to know this adjective describing these angles. What is an acute angle? You have an acute angle. When we say acute angle, A-C-U-T-E, acute angle. This is an angle. If that angle is A, we're saying that that angle is greater than 0, but less than 90 degrees. This is an acute angle. An angle that is greater than 0, but less than 90 degrees. We shall come across the other ones, like obtuse angle. Obtuse angle. In this case, the angle A is greater than 90 degrees, but less than 180 degrees. This is an obtuse angle. We call them angles that are greater than 90 degrees, but less than 180 degrees. And lastly, we have a reflex angle. Reflex angle. You can see the pattern. If we say it's angle A, so we are saying that that angle is greater than 180 degrees, but less than 360 degrees. So whenever these words are mentioned in a problem, acute angle, obtuse angle, reflex angle, you should be able to tell where that angle falls, the range of that angle, from where to where. Acute, that angle is bigger than 0, but it's less than 90. Obtuse, that angle is greater than 90 degrees, but less than 180 degrees. Reflex, the angle A, if it is reflex, then it must be greater than 180 degrees, but less than 360 degrees. So it is between this range, 180 degrees to 359 degrees, if you want to. Yeah, there is a way to draw them, but no points. This one here, acute angle, this acute angle here, it's greater than 0 but less than 90. 90 degrees would have been like this. Yeah, but it's less than 90. Obtuse angle, This is greater than 90, but less than 180. This 180, yeah? So this is A here. Yeah, this is A. It's greater than 90. 90 is here. Greater than 90, but less than 180. Straight line is 180. This one is 360, yeah? So we normally do it like this. It's greater than 180, but less than 360. And yeah, less than 360. Let me do it the vertical way. So that angle is all the way here. This is A. It's all the way from here. This is your 90. I'm just illustrating. So it's greater than 180, but less than 360. That is the angle A here. If you want to watch the picture form, so that is the understanding. Yeah, I hope this helps, because you will come across these words: acute angle, obtuse angle, and reflex angle. Now let's go to the problem. It's already 7 minutes. It's long now. So we are told that sine A is equals to 4 over 5, and sine B is equals to 1/2, where A and B are both acute angles. Calculate the exact value of A sine A plus B. So let's start with sine A plus B. Sine, my marker starts, they start. Sine A plus B, we already know from our angle addition formulae that sine A plus B is equivalent to the sine of A, the cosine of B, plus the cosine of A times the sine of B. So this is what you have for this formula. We expand this, you get this. Sine A cos B plus cos A sine B. Now, here we are given sine A. We know what sine A is. It's 4 over 5. So we have 4 all over 5 times the cosine of B plus, we don't know cos B, cos A, sorry, but we are given sine B. Given sine A and sine B, so we are given the sines. So here again, you have the cosine of A multiplied by sine of B, which is 1/2, times 1/2. So now what is cos B and what is cos A? What is cos B and what is cos A? We need to find the value of these identities, cos B and cos A. We only know the sine A and B. What is cos B and A? So this is where this description of acute angle comes in. For us to be able to find the exact value, as the problem states here, of cos A and cos B, we have to go back to the problem and see what range of those angles it should be. So here we are told that there are acute angles, so we can draw our triangle here, right angle triangle, because we know for an acute angle, the angle must be greater than 0, but less than 90 degrees. So if we say this is our A, correct? This is our right angle triangle. This is angle A here. That's what we are looking for. We are looking for the cosine of A and B, sine A cos B plus cos A sine B. Right? So now, if this is A, and we are told that sine A is 4 over 5. So what is sine A? What is sine A telling us? Sine A is opposite all over the hypotenuse. So if this our angle here is A, so we are claiming that sine A is opposite all over hypotenuse. So the opposite side is 4 and hypotenuse side is 5. So this is one of the basic right angle triangles when you are considering Pythagoras theorem. So you know that this side here is automatically 3 according to Pythagoras, yeah? 3, 4, 5 triangle. Pythagoras theorem. You know how to find this. The square of this is equal to the square of this plus the square of this. So now from this triangle there, we can now solve for cos A. So what is cos A? You know that the cosine of A is equal to the adjacent. So cos A, the adjacent is 3 all over hypotenuse, adjacent all over 5, cos A. Right? So you now know cos A is 3 all over 5. That is what we want, cos A, because we shall come to cos B. So cos A, where shall I keep it? I want to keep it somewhere. Cos A, cosine of A is 3 all over 5. We now need the cosine of B. Let's keep this one here. So we now know cos A is 3 all over 5. So this problem now becomes 4 all over 5 cosine of B plus, now cos A is 3 all over 5. 3 all over 5 times 1/2. It's not finished yet. We now need cos B. For us to find the value of cos B, we have to use sine B in this right angle triangle to find cos B. We wanted cos A, so we use sine A here, 4 and 5. So this triangle now, we need to modify it. It's changing now. Everything changes by this triangle. So what we have here is B. Now is B. So when you look at sine B tells us, sine B says that it's equivalent to 1/2. So what is sine? Again, sine is the opposites of the angle in a right angle triangle divided by the hypotenuse side. And we are given that sine of B is 1 all over 2. So which means sine B, the opposite side is 1, the hypotenuse side is 2. That's what this problem is saying. So now we know where 1 goes in and we know where 2 goes in this right angle triangle. So what is this third side? This is the adjacent side now to the angle B. What is the value of this third side? I don't want to go into that, finding the Pythagoras, using Pythagoras theorem. You know how to use Pythagoras theorem. This side will give us root 3, the square root of 3. You know that. You know that 2 squared is equals to 1 squared plus, if this was x here, will be x squared according to Pythagoras. So this is 4 is equals to 1 squared is just 1 plus x squared. Now I bring this one here, so it's going to be 4 minus 1 is equals to x squared. 4 minus 1 is 3 equals to x squared. So I want x, so therefore the root of 3 is equals to x. This is how we got to 3 here from Pythagoras. I hope you know how to do that. Correct. So now we have this. So from here, now we can find the cosine of b. So the cosine of b, we know the cosine is adjacent all over hypotenuse. So what is adjacent is root 3 all over hypotenuse is 2. So this problem now becomes, it's getting long. Sorry, I keep changing markers. My markers keep getting drier quickly. So this problem now becomes, now we know what cos b is. We now have here 4 all over 5 multiplied by cos b, and cos b is root 3 all over 2 plus 3 times 1 is 3, 5 times 2, let me see, it's 10. Yeah? 5 times 2 is 10, so 3 all over 10. Let me simplify. So I bring this problem here. This again, you have 4 root 3. Now it's 4 root 3 all over 5 times 2 is 10 plus 3 all over 10. So your final answer becomes, we have 10. Yeah, for your final answer becomes 3 plus 4 root 3 all over 10. This is the final answer. 3 plus 4 root 3 all over 10. Thank you for watching. Bye-bye. We'll now move on to the second problem in the next video. Thank you.